Once you get into a multi-gateway architecture, once you get beyond that, and especially once you start hitting the cloud, the complexity, the management, the infrastructure gets to be a lot for the end users to manage, for you, the end user, to manage. This architecture that we talked about last week was a site level architecture. A lot of people asked me where it fit, and a lot of people asked me to review their architecture afterwards. And the key piece that kept coming up was they all thought that I was talking about an enterprise level cloud-based system, where the intent of this architecture is very much the L2 SCADA layer ignition architecture. You can have some of your MES functions, especially the core 4 that are commonly found in your MES, your scheduling, work order management, downtime, and OEE. The thing from there is what you do at the enterprise level, how you scale that up to 100 sites, 10 sites, 50 sites, 1,000, and how you manage that to maintain that at scale. A lot of the SCADA-focused MES platforms out there, a lot of them built around Ignition, really focus on the core 4. Specifically, a lot of people talk about OEE a lot, and a lot of the times when an integrator tells you that they are implementing MES, it's really an OEE engine in disguise. So then when you actually need MES, what does that mean? It's more than just core 4. Core 4 is a great place to start, but you're going to run into recipe management, advanced scheduling, warehouse management, maintenance, laboratory systems. You're going to have energy management, advanced analytics, regulatory compliance, and all sorts of other things that may or may not apply to you. But all of these need to be considered as optional features in your MES. And while you could build a lot of these out from scratch, and a lot of integrators can, then the question is who's left holding the bag after they leave. And when they build their system in Ignition or any other platform, I'm trying to do this one without starting a flame war. When you're starting your MES journey, you typically start by learning about and implementing some version of the core 4. With this, some people start with a Ming stack that is Mosquito, MQTT broker, InfluxDB, Node-RED, and Grafana. It is a free open source stack that a lot of people start with. It's really good for the lab, and I played with it myself, but that doesn't usually scale to production. So when we get into production, then we normally start implementing those same 4 features in platforms like Ignition. And at a single site rollout with an ad hoc team of internal developers or integrators, you can usually build those core 4 functions pretty well. From there, though, when you want to grow into bigger systems and more advanced functionality, such as much more advanced and automated scheduling based on various forms of linear math, recipe management, full warehouse management systems, or things like that, maybe you need some regulatory compliance, some formulation management, or even employee training management. That's when things start to get complicated. You can still build these in platforms, in your SCADA systems, but eventually the complexity gets out of control. You get at a site level, this will work, especially while you don't have enterprise standards. When all of your namespaces are blue and there aren't enterprise standards that require you to do things in certain ways, you can just go in and build a very scrappy MES platform in your SCADA system. You can go even further if you're using modern composable SCADA systems. Things like Ignition can take you to the enterprise level from a purely technical standpoint. The complexity comes in once you start having to deal with all the different databases, the schemas, all the wiring and piping between these different systems. Once you get into a multi-gateway architecture, once you get beyond that, and especially once you start hitting the cloud, the complexity, the management, the infrastructure gets to be a lot for the end users to manage, for you, the end user, to manage. And with that, the house of cards usually starts to fall. The technical debt builds up, piles up. You lose sight of which databases even exist, what features are in those databases, and who owns what. IT and OT start to fight with each other, and everything just kind of becomes this political mess. Integrators have their part. Some integrators have their stuff locked down, others are open, and you've got this mix-up bag of various features that were bolted on over the years. And while it should resemble a microservice architecture, it ends up just being an ad hoc mess of point-to-point solutions. Change management becomes impossible. Change management is much more on the cultural side of this. So when you're doing a multi-site rollout at the enterprise level and you need buy-in from all of your sites and all your operators, not at one site but at many, then you need to have the culture in place that is accepting of change, champions change, and wants to improve. And that has to go all the way from the CEO all the way down to every operator and all the way over to every department. From maintenance to operations, everybody has to be looking out for each other and trying to get better as a whole, even though they have their own missions, their own goals, and their own metrics that they have to hit. It goes down to the incentive structure and the entire culture of the company to make that happen. But before we even get to change management and all that, we get into where the SCADA-based MES starts to fall apart was that level of complexity. Well, an integrator could come in and build you a very well-built, fully featured, and fully functional MES at an advanced level. There are a few who could put in a good warehouse management, a recipe management system for you on top of the Core 4. But then when they leave, the question is who maintains that and who owns that. At which point the handoff becomes important. But if there's nobody on your team to own those systems after the handoff, then they just kind of fall apart. So that's where you get into the difference between SCADA-built MES systems and true enterprise-grade MES. True enterprise-grade MES is usually entering through the boardroom. You're going to have various forms of executives, directors, and VPs are all going to be involved in selecting these things. And that's where the culture becomes critical, is how to choose the right one and how to include a center of excellence team or other team with mixed skill sets. But yeah, so the enterprise grade MES gets you MES system that you build inside of your SCADA falls on the build side of the build versus buy spectrum. Well, it's not a fully built custom raw code MES-based MES system. It is built in a platform, custom and ad hoc to you, which sounds great and can be, depending on who's there to manage it. The other side of the spectrum is the buy side, where the danger comes in with the inflexible MES systems. In this case, that means that this is a blue namespace. There are very few and far between corporate standards as far as what tags need to look like and how and why we're doing things. A lot of sites that could be alongside this one might still be legacy brownfield sites running various legacy SCADA platforms and systems and architectures. Some may not even have any. But this one on this customer has this architecture, this tag gateway-based architecture. And so the blue namespace here is the place where people can build, where they can solve their own problems in tools they have access to without the burden of overmanagement and over-standardization. This represents the bottom-up approach to digital transformation that we commonly hear about in Industry 4.0. That said, we don't believe that the bottom-up approach works alone. In fact, the entire branding of our company was built on that belief. We also don't believe that the top-down approach works either, as there is a lot of data that proves that, 70, 80, 84%, depending on who you listen to. But we do believe that simultaneously meeting in the middle of the top-down and bottom-up approach simultaneously works together. It's top-down and bottom-up, not top-down or bottom-up. I say that because that answers the question about what this architecture was designed to facilitate. This architecture is the bottom-up approach. This is the place that people can solve their own problems, where they can be operations, where OT can be OT and not be burdened by the standards and practices forced upon them from the enterprise. And that's where landing a best-in-class SCADA system on-premise locally allows them to solve their own problems. Using tools like Flow Software and Ignition allow us to do analytics and proper SCADA at the edge. It allows us to build out our Core 4 functionality if we need to on our MES, our OEE, our scheduling, our work order management, and downtime tracking. But it doesn't require that we do. Again, everything we build on this stack should be here to solve a problem. Where this comes in on the other side, the top-down approach, is IT's domain. That's where we didn't get too much into it because it's a much more opinionated domain. And it's a domain that has to be enforced from the top down on every site.